The discussion that we had so far when talking about metallic behavior, electronegativity, atomic size, or ionization potential was for neutral atoms. For neutral atom, and that's a very important distinction because for neutral atoms, you can see those trends. However, as soon as you start making ions, the trend may change because now you need to not just think about where that ion is in the periodic table, is how many electrons it has, how close to the nucleus, and therefore how strongly attracted they are, etc. So the discussion of ions makes the trend that we've been talking so far kind of useless. However, there's still some trends that I think it's important to remember. And one of them, for example, is when we look at metallic behavior, we will see that metals, so all these elements, will, when combining with other elements and when forming chemical bonds, they will tend to lose the electrons. Why? Because if they have metallic behavior, they typically have a low ionization energy, therefore a low electronegativity. So that means if they lose electrons, they will tend to form cations, positively charged atoms. On the other hand, the nonmetals, because they have a high ionization energy, they will be very much attached to the electrons they have. They will capture someone else's electrons. That means that they will gain electrons, and they will typically be anions. There may be some exceptions, but they will typically be anions. Okay, and it's important then to realize how size and how ionization energy of ions will change. And the position of the periodic table is not important. What's important is how many electrons and how closely attached to the nucleus those electrons in the ion are bound. So let's first talk about radius. How does the radius of an element change once you remove or add an electron? Well, if you remove an electron and you form a cation, in this case, imagine this would be helium if it has 2 electrons and 2 protons. And if you form helium plus because you remove 1 electron, notice that the nuclear charge has not changed. Therefore, the electrons will not be repelling each other. There's a little bit of a repulsion here that will disappear once there's only 1 electron. This means that the electron will be more strongly attached. Therefore, the cations will always be much smaller than the neutral atom. And if they are much smaller because they are more strongly attached, expect the cation to have a higher ionization energy. That means it'll take more energy to remove that second electron. What I'm just saying here, of course, is that the first ionization energy will be smaller than the second ionization energy. Okay? Now, if you add 1 electron, notice that the repulsion that existed before, it has increased. Now, the nuclear charge has not changed, but the repulsion among electrons, because they have the same size, increases. So this means that if the repulsion increases, the electrons are trying to stay away from each other. The trend will be that the anions will always be much larger than the neutral atom, and therefore, of course, the ionization energy of the anion will be smaller than the ionization energy of the neutral atom. It'll take less energy to remove this guy because what we just did is just include some repulsion. Okay, so let's see if we can apply this to some simple problems. In this case, it's asking to rank each set of ions in decreasing size. All right, so let's start with A, and we see calcium, strontium, and magnesium all having the same charge, whereas magnesium, calcium, and strontium are right here. Notice that you can just apply the same trend because now strontium 2 plus, the electronic configuration of strontium 2 plus is krypton, just krypton, and the electronic configuration of calcium is just, let's see, argon, and the electronic configuration of magnesium 2 plus is just the electronic configuration of neon. We remove 2 electrons, and so notice that we have just removed electrons, but the amount of electrons being removed is the same, so you can expect to see the same trend as you go down. The size increases, so the size of calcium will be larger than the size of magnesium, but calcium will be smaller than the size of strontium just by their position on the periodic table. A more intricate problem may be this case, when you see potassium, sulfur, and chlorine. Potassium plus, the sulfide ion, and the chloride ion. What is the electronic configuration of potassium? Notice that it's just argon. What is the electronic configuration of the sulfide ion? We just added 2 electrons, is argon again. And how about chloride? Notice that it's argon again. So they all have the same number of electrons, right? All these ions have the same number of electrons. However, which one of these elements has the highest nuclear charge? In other words, for the same number of electrons, which of these elements will be able to attract these electrons more strongly? It'll be the element with the highest nuclear charge. Notice that potassium has 19 protons. Potassium has 19 protons, that's what makes it a potassium. Sulfur has 16 protons, and chloride has 17 protons. 17 protons. This means that because the nuclear charge of potassium is higher, they will attract the same number of electrons more strongly. Therefore, it'll be smaller. Potassium will be the smallest of all, followed by chloride, followed by sulfur. Sulfur is the element with the lowest number of protons. Therefore, it will not attract as much. That means that the electrons will not be as close to the nucleus. Therefore, it'll be a larger atom. In this case, in the last example, you have gold plus and gold 3 plus. The difference between gold plus and gold 3 plus is just that we removed electrons. So this means that they have the same number of protons, but in this case you have 2 electrons less. If they have 2 electrons less, the same number of protons will be able to attract those electrons more closely. This means that the size of electron 3 plus will be smaller. The size of gold 3 plus will be smaller than the size of 1 plus, because they have the same number of protons, but that same number of protons will be able to attract more closely if it has less electrons.